Good afternoon and hello everybody. I will talk about indexing a complete database from scratch today. So there will be nothing there, how would you index that? I'd like to introduce myself. Okay, does it work? It doesn't work. Somebody. Okay, who is? Okay, let me see. It worked before. It doesn't work. Do you need this? I have one of my own. So let's see if this does work. Oh, of course it doesn't work. Of course it doesn't work. It's not switched. It's not switched to it. That's the reason. Now, let's try. Okay, here we go. Fine. Okay. Yes, I'd like to introduce myself. I started with Oracle Database version 5 more than 25 years ago. My name is Lothar Flatz. I'm an Oak Table member. Oak Table is the secret group of data scientists. We have 3 people here. This is Peter, with me, myself, and Timur. I was a member of the Oracle Real World Performance Group, which is their elite group for performance issues. I've got 25 people worldwide, 4 of them in Europe. And in 2012, I quit my job with Oracle after 15 years. There's some reasons for that I don't mention now. I'm also called an Oracle Ace, so this is also a kind of elite selection. I'm working for a small company in Switzerland. We've got 36 people right now, continue to grow, and we do for most of them are doing development in certain areas. There's database development, there's also Java development, and SAS. All right. I'd like to start with mentioning one of CORD's rules. It's one of the 12 rules that were defined what a relational database is. And this rule says everything that's in the database can be accessed by that same language. And in our case, that language is SQL. So we are doing a very generic talk today. It is basically about Oracle, but this is only the foundation. But above that, it is talking about indexing and SQL. So it's very, very generic. And yes, you should benefit from it as well. It doesn't matter. It could be Postgres that will be used for it. It could be DB2, could be SQL Server. So it doesn't make a big difference here. We are talking about how is indexing done best. That's the basic idea of it. So when I wrote an article for a series of articles for the Northern Californian User Group magazine, which is the oldest Oracle user group, obviously, in the world. And they were called Raiders of the Data Dictionary. And when I started to write this article series, I said my first article is named Fact-Based Indexing. So indexing based on real facts, yeah, instead of guesses. Yeah. And my friend Tim Gorman said, oh, this is a boring title. You should go for something more interesting. And I said, well, Tim, okay, what should I do? Yeah, what should I use as a name? And he said, what are you talking about? I said, well, I will be talking about that in the database we've got important information about how the application works. And we could use this information to make the application better, any application. Yeah? So for example, for indexing, we have got some good information. This is our SQL statements. And we could use this information to make our indexing better. And then he said, well, obviously, what you query is the data dictionary of the database, and you're trying to get some information from there. Yeah? So call it Raiders. Raiders is treasure hunter, yeah, of the data dictionary. And well, I adopted the name. It's more interesting, obviously. And instead of fact-based indexing, it's also called Raiders of the data dictionary part 1, and that's indexing for the workload. So I hope you recognize the sound. It's Indiana Jones part 1, Raiders of the Lost Ark. So there's the connection, the radar. Well, it all started years ago when I had a coffee break with one of my customers, DBA, and we were sitting there, and the guy told me, well, you know, our application, I think the indexing is all broken. It's a mess. And if I could, I wanted to do it all from scratch, all new. Yeah, I hate it. I think it can't be repaired. We should make it new. And then I said, I think you were right. That's true. So at this point in time, at this customer, we didn't have the chance. The chance did come along some years later. But before I start my presentation, I just want to switch on one rule. I know everybody knows about indexes. And I think indexes in Postgres, indexes in Oracle, indexes in a relation database, whatsoever, it makes no difference at all. So you all know about the topic, and you all have an opinion about it, but please, let's wait for the question section. It will come soon enough, and then we can discuss. Because if we got through in the presentation in discussion, I think we might lose a lot of time. So just no discussions. During the presentation, we have a question section at the end. Well, okay, so the main issue everybody knows. When you write an application, and you are a developer, and I was a developer, used to be a developer as well, and you sit down and you have to guess your indexes. Yeah? You don't know the data, and you don't know which company it will be used, your code. You have to guess your indexes, and that's actually a bad situation. You are all by yourself. So can you come up with the best possible indexing? Certainly you cannot. So actually it's a good idea, once the application is running, to rethink indexing. Do it again. It is rarely done, but sometimes it is done. And of course you come up with better solutions then. I had one customer who had a very complex application. They had different time dimensions, and the indexing was particularly difficult to do. And this customer was so desperate. They were a service provider for health insurance companies, and they had their smallest health insurance company move to the new software. And then they called somebody in from Oracle, and my colleague worked 60 days on site tuning that stuff, and that was their smallest customer. But now they wanted to have their biggest customer on that new application, and they were afraid. And I told them we should do the indexing from scratch. And my colleague who was working there, she was also senior principal consultant from Oracle, she said, I'm afraid to do it. Can you do that? And I said, yes, I will. I'm not afraid, I can try this, as it had never been done, but the situation is so bad, and that application was so broken, yeah, that we said, okay, we go ahead, we do it. We do it from scratch. So first thought was, Evgeny, you asked that question as well. Can we automate that? Yeah, there's advisory tools. In Oracle, there's a SQL advisor, and you throw a query in, and it gives you an index recommendation that comes out of it. Yeah, of course. Could we automate it? Yes, maybe we could. Yeah. First, will you trust it? Yeah. You feed it with SQL statements. It comes up with some index structure. Yeah. You don't understand the result. Will you trust the result? Do you think it's good? I don't. I didn't want to bet my career on that. This is an important customer. They want the re-indexing. Has never been done, and I should rely on a tool. No way. I wouldn't do that. And there's no intelligence in that tool. It doesn't understand the application. It doesn't understand what a time column is, what the time dimension is, what the date is. It doesn't understand the purpose of it, and we should blindly trust that. No, we couldn't do that. We need more intelligence in that task. This is a difficult task to do. So what we said instead we'll team up. Yeah, we will have the DBAs on board, we will have the developers in, and I was the external consultant on that job. Yeah, so we make a team, and we do this together, and we use human brains for it. So what do we want to achieve? Well, we want that we cover all important queries, so we want that to be complete. Yeah? All important queries should be supported by an index. Second, non-redundant. Yeah? No index that's not needed should be there. If I have an index that could do the same task already, I will not have a second one for it. And that's almost the same as minimal. Yeah? We want that to be the least number of indexes possible, because every index needs maintenance. If you do an insert, you maintain the index. You might have asked once the question, if I do an index with into a table, how much will with one index slow this down? Yeah? Well, I did the test on Oracle, and probably it's the same on Postgres, but you can try yourself. You can write in the books that it says 100%. Yeah? So with one index, an insert is slower, 100% slower than with no index. And I can say this is only true for one row. To a couple of million rows, and you will see, no way. It is between 200 and 300, maybe 400%. Yeah? Because it hasn't only to do the index maintenance, it has also the balance to the index tree. Yeah? So this is more work to do, actually. Okay, is that bad? Yes, it is. It depends. You know, if you insert one row and it takes 100th of a second, and then you have an index added to that, and it takes 200ths of a second or 300ths, who cares? If it is online, yeah? Who cares? Nobody cares about that. But if you have a data warehouse and you want to insert 1 million rows, then it makes a difference. It makes a real difference. Okay, so therefore we want our indexing to be minimal. The least number of indexes possible. That's what we want. And it should be efficient. Yeah? It should be an efficient support for the queries. Yeah? That is the target. How do we do this? That's ambitious, is it not? I think it is. I think it is. Well, the first thing what we needed to decide is, will we patch? So we have an existing index structure, and we could add one index here, one index there, remove an index from there, and then at the end we'll have something. Will this be efficient? We don't know. Will that be minimal? No clue. So I said, I don't want that. I don't want a discussion about every index. Is it needed or is it not needed? No, if we have to go, we go. This is no way. we do everything new. So all the indexes away, yeah? And do it from scratch. But right, this time we do it right. Okay, so we came up with some rules. So naming conventions, how do you want your index to be named? Because we had to do scripting, so we needed a name to fund by a program. Some basic design principles. For example, we decided on foreign keys, and the decision was, in the beginning, we will put all foreign keys in. Later on, you can take them out if you don't need them. But we start from scratch with a not proven index structure. And we don't go risk here. We put all of them in. Why do you need a foreign key? There's two reasons. I don't know in Postgres, it might be the same thing, quite likely. It's two things, actually. If you delete a parent and you don't have the foreign key indexed, it will create a transaction log, and then it will sequentially search and find if there's any related child records. It will take a long time. Your transaction log is open for a long time. Therefore, you need to index your foreign keys. And then there's a second reason for nested loop joins. Yeah? Nested loop joins, they can only go from parent to child if you have a foreign key index. Yeah? So half of your nested loop joins will not be possible if you don't have a foreign key index. So no discussion about that. Yes, you index it. And then we decided on some minor stuff with physical attributes, which will be the index table space. Not very important that. And then we had a long phase of collecting data after we made that. If you want to catch all the important processing, you will need to catch your daily processing, that's easy, your weekly processing, if there is any, and the monthly processing, that there will be any. Yeah? So you have to wait at least 1 month to get everything collected. Yeah? So in this case, it was 3 months. Our collection period was 3 months. What did we do? We were looking into various sources, and here it's probably getting now Oracle specific, but you will have other sources with Postgres. It will work quite the same. There's some internal tables here. Yeah, so syscall usage dollar says how often is a column used in a query. Yeah, there's a counter process in Oracle which is counting up for every use. Yeah? So it will give you the information that column product name was used in 10,000 times with an equal comparison and 2,000 times with a greater or something like that. Yeah? So it says that. How often is it used? So it will give you more or less a hit list of used columns. Yeah? It's used for something else, but it's not important for our task. $SQL plan is an internal representation of the execution plan. And I wrote a little script that was collecting also the information on which columns are used together, yeah, in a search. So for example, if you have a table person, then first name, last name are quite often used together to find people. Yeah? So we need, this will only give you the his list that I have 10,000 queries with first name and I have also 10,000 with last name. Yeah? But here it says which are going together in the same query. Yeah? This is one thing I need to know as well. Then we have a history of plans. You might not have that. Then here's the SQL statement itself. You can also go there. Yeah? But it's a bit easier to go for this here. And I wrote a script that was sampling every 10 minutes, was going into the database, scanning this information and writing it off to a table. Yeah? So this this was the basic idea how this works. And here you're going to see what the result was for some simple example. I apologize, the names are in German. So this is our real result. And you can see that this Kund here, that means customer. The rest is rather easy for you. So it says customer ID was used 129 times with an equal comparison. It's never used with a greater or smaller comparison, never in a like predicate, but it has been used 165 times in a join, in an equal join. Yeah? So as you would expect, it's quite simple. So this is an example for such a hit list. And I can see for customer ID is the column that is used the most in the queries. Yeah? Then we have got the column, here the column statistics itself. And it says, here's the customer insurance number, and it has 3 million distinct values. Yeah? So how good is this column as a selection criteria? I can get from the dictionary as well. It's not important only to know how often it's used. I want to know how good it is. Because it's not very selective, then I don't need an index. Makes no sense. So I need this as well. And here's these column combinations, as you can see. So this has been derived from the SQL plants, collected with a job that was going in every 10 minutes, and then wrote off how often I find this combination. So you can see that, the customer ID, for example, was in 84 different queries, and those queries had 3 million executions. Yeah? So now I have the fact that I can use to make my indexing. This is all I need. Let's just back up here. Yeah? I know how often a column is used in a query. I know about the combinations of columns. Which columns are used together? Which can I combine to an index? I know which columns are selective, which can stand for themselves, and I know which ones I need to combine to make a good index. So pretty much I will be now ready. Yeah? Now I'll be ready to make a perfect index structure. And there was this Sunday, when everything was collected, and my customer expected me on Monday to present the solution. I was sitting there. We've got everything now. And I was sitting there and said, well, if you have this, how would you make a perfect index structure, or almost perfect index structure, yeah? with that information? And I needed to solve this right now, because I won't be ready by Monday. And now I got a kind of an internal conflict. Yeah? We all have two brain halves, two brain hemispheres. Yeah? There's the right brain hemisphere, which is the idea of the source of our good ideas, of our creativity. Yeah? And there's the left brain hemisphere, which is the source of our speech, of calculating. Yeah? So in order for an idea to be put into words, it needs to go from right to left. Yeah? There's a little thing in between that's called corpus callosum, and we have to go over this bridge. So my right brain was saying, you get everything that you need, and you'll be ready to make a good index structure right now. And my left brain was saying, how? How can I do this? give me a sentence, give me a rule, give me an approach, give me a recipe. Yeah? How can I do this? And the right brain said, "You stupid. Go ahead and do." Well, I didn't know how. And here you can see this conflict is a little mean slide. It says that one is yellow. The word is yellow. Yeah. So your left brain reads yellow, but the right brain can recognize colors and says, "No, it's green." So this is this internal conflict put into a slide. You can see this. When you read this, you can feel the trouble in yourself. And I was sitting there, I was rather desperate, and it got later and later, he didn't come up with an idea. But then I finally resigned. And then the idea was flowing in, yeah? I was starting to draw on paper, draw something, and suddenly I realized that I was drawing the solution. So switch off your left brain and let the right brain do the work. Let the right brain give it the flow, and maybe it will solve your issue.
I suggest you try it again, Lou. This time, let go of your conscious self and act on instinct.
With the glass shield down, I can't even see. How am I supposed to fight?
Your eyes can deceive you. Don't trust them. Stretch out with your feelings.
So this should be a little help for you if you got stuck sometimes. Yeah, forget about the whole trouble. Let the source flow. Maybe draw something, and maybe it helps. And then I was coming up with the idea, and the idea was, you see, basically what we have is this. Yeah, this is a collection of columns, of a collection of lists. And we will need to make the best possible index structure on that basis. How will we do this? Yeah? How will we do this? And the answer is, you have to apply some order to that. Yeah? You have to apply a sorting scheme. Yeah? And then the next thing is, what is the most important thing with indexing? If you define a complete index structure, what is the most important thing? And the answer is reuse is the most important thing. We want to define an index that can be used for the maximum number of queries possible. Yeah? So, what does that mean? It means, if I have an index, or which is like here, customer ID, yeah? And customer ID is, like, say, already distinct, yeah? So it's unique, yeah? If I see another combination which is starting with customer ID, like this one, for example, I can forget about it. Just throw it away. It's not needed. I have an index here. I don't need another one there. So it is the order of the columns which is important. And what columns which go on front, what will be in the first position? And the answer is simple, the ones that are used most in the queries. Because that will be the maximum reuse, yeah? The best possible result. So what I did was simply, here we have the ranking, which columns I use the most. I give it a rank. So number 1 is customer ID, customer status is number 2, and so on, and so on. And then I sort my combination based on the rank. That's the answer, simple. Well, once I have this, once I have them an order, I can apply some rules to that. So I can say, for example, if I have these 3 combinations here, last name, first name, and age on a presumed table person, and I have last name, first name, and last name by itself, only the first index is needed. The others are not needed. But I can only see this when I have a sorting, when I have an order to it. So I need to order first, and then I can apply rules. For example, there's another example. If I have this combination, last name, first name, city, last name, first name, zip, maybe I can combine those two into one index, yeah? Because last name and first name is already pretty good search criteria. So I have only a few people which have the same name. And zip and city, as the third criteria, it might be okay to combine this to this index, yeah, which is for the search of zip not quite as good, because this you can find via the tree, yeah. And if you're looking for zip, then inside the same name, you will have sequential search on the tree leaf structure. But it's still acceptable, because on that same name there won't be a lot of persons normally. So it's acceptable. And you'll have one index less. You can have 1 instead of 2. And this reference that Jonathan Lewis is pretty famous, and he was blogging about that same thing. He was also suggesting such an approach and came up with the same idea of sorting by reuse. So maximize reuse by putting the most used columns in front. And you can see here, this is the most recent example. It's only a couple of weeks old from a customer. And this is the columns, and the column behind that is bill, yeah? Some bill structure, and you see this. Most of them are starting. This is actor ID, this will be the customer, and then it's bill ID with that. And once you have sorted, you can easily spot, okay, for example, what we did as well, was to say, how good is the first column? And this says, how many rows will I find when I only use the first column? How good is the first 2 columns? How selective is this? So you can see here, for example, bill ID is already pretty selective, and actor ID as the second is coming down to 1 row. So I can do away with this index. I just use this one, and I delete all of those, up down to here. So it's pretty quick. So I have automized this data collection step. I have automized this step of creating an Excel spreadsheet. But in the Excel spreadsheet is still manual work. So this is how we use that today. Okay, so if we could go rid of a lot of indexes, and it's pretty simple. As you can see, for example, here, bill ID, roll code, it's pretty much similar, yeah? So you can go through this rather quick, yeah? So throw indexes away, and in the end you have an Excel spreadsheet with the remaining indexes. We can feed this into a generator and do create index statements. So that worked pretty well. We generated the create index scripts. Drop all existing index, rebuild the index structure from scratch. Then we did, obviously, load tests, batch programs that we run, real application testing, which is a kind of capture online activity and then replay it on our test database. So we did pretty well on that. We put some indexes we know about from previous tests back in place. We had also monitoring scripts that were, okay, good. They were checking if there's some missing indexes. and there was some manual patching with that. So, as I said. Okay, what was the final result? We were saving 30% of the index space. We had faster patch programs, and what was a bit unexpected but very good, plan stability. If there is only one index for a certain query, then the optimizer can only choose, do I need it or do I not need it? Yeah? If there's 10 different indexes that the optimizer could use, it can use once this, once another one. It's not, your plans can change much more often, and it's more difficult for the optimizer. Here you make it easier for the optimizer. Use an index or you do not use an index. No other question. So it was more stable. We needed 90% less memory on a buffer cache than the software vendor was recommending. They were actually recommending a terabyte of buffer cache in 2007. Who had a terabyte of memory in 2007? I don't know anybody. Okay. So we could do away. It runs stable for years and years, and we had never the problem back again. Recently, there was a DBA group leader from another company visiting this place. This company had the same software, but without this index structure, and they said, I like the DBAs on their place, they're so relaxed. I want to have that too. So there was no issue, there was no trouble coming back. Okay, so always good if you base your work on facts. No, the number of queries that were monitored, this is hard numbers, this is no guesswork involved, and then we can do good job. So thank you very much, and we have now got some time for questions. Yes?
Do I need a microphone? Hello, I'm Alexander. Thanks very much for this. I love the approach with all my heart, and as you being German, probably, or Switzerland?
I'm Austrian, but
Austrian.
I live in Switzerland, yeah.
I believe it's all the same in terms of the human nature, because the approach is so straightforward and so logical. And I bet it should be somehow pretty well implemented in terms, not the built-in tools, as you said, the built-in Oracle advisors were not too good in solving your case, but still, have you ever come to an idea to create something like the advisor, your own advisor, that will come up with some set of indexes with all the intermediate calculations and spreadsheets, just to explain why these indexes? Or basically to automate everything you did, but to be it as a repeatable solution for other clients as well.
Yes, I actually built a tool which is creating the Excel spreadsheets. Yeah, up to this point, it is scripted. Yeah, and we implemented that at other customers, and it is automatic. Yeah, but the final step, you know, the really creating of that index structure, for me, you can create a rule engine that does that, basically, or maybe artificial intelligence. But I do not have the time and not really the ambition to do that. I just say I would rely on human thinking for that.
There should always be a place for a human to at least watch after this tool. But still, is this tool freely available for everyone? Or is some kind of internal tool you are using for your own needs?
I've not seen it. Well, you can write me a mail, and I will provide you with a query. But it is based on the Oracle structures, of course. Yeah, and that's been weeks to create that.
I see. And one last question. It's a bit off the original topic. You said that you worked out some naming conventions on how did you name the indexes. Can you please share your experience? Because I used to work with a lot of applications and databases, and the naming conventions are jumping off on each example?
That's very simple, you know, the naming convention. Is primary keys start with BK underscore, foreign keys start with FK underscore. Then we had SI, which was called for search index, and that means it is there to speed up searches, yeah. And then we had TUN for tuning index, no, TI was it, excuse me, for tuning index, and there was a covering index. So this is the case where in a nested loop, you will pick up a lot of data, and the covering index does also cover the columns which are selected, not only the ones.
You don't need to walk into the table to get
Yeah,
this.
index only access, no table access. Yeah, for some cases you need that. So these were the naming conventions, and then was the first letters of the columns which are in the index. So you could.
3 technical prefixes, and then the rest remainings of characters that Oracle allows you to
Yes.
use for names.
Yes, at this time it was still 32 with Oracle version 12.2. We've got some 100 whatever letters.
It's a relief.
Yeah, I don't know. We're used to the old ways. So
Okay, thank you very much.
you're welcome.
Oh, my name is Alex, and I would like to discuss how do you select index types. From what I've seen, I don't see a place where you could select index type. Is it whether order by desk, or is it whether bitmap, or probably function based? Where is the place where you identify types of indexes, or you weren't considered about it, just fields?
Okay. Well, actually, as far as function base goes, they will go under columns. You know, it's a calculated column rather than a column in the table. There should be some place here. Here we see they were using NLS upper, for example. So this was just treated the same way as a column, yeah, and just an expression instead of the column works as well. Then bitmap, it was an online application. Bitmap would have been a strange case for that. So there were no bitmaps that were not considered. Yeah.
But I think a case with desk indexes is
Descending, yeah.
yes. So
Yes, it's,
how could you see it? Because there is nothing related with order by in queries here. So you should parse order by somewhere.
you know, I'd simply say you're correct, but that would have been too complicated to do. Yeah, you know, even that what we have right now is complicated enough. There was some special case stuff that we know. This is mentioned here in that part of the presentation. It's pretty at the end. Top all existing indexes. Yeah, manual patching. Yeah, we put in some indexes that we know from experience that needed to be there. Yeah. But you're quite right. If you, for example, do a select maximum with the criteria, then I have to do this column descending to be the quickest access. But I don't. It's too complicated to automate that. Yeah.
And a question. So, if I were you, probably I would start it from switching on index monitoring. Checked Oracle dictionary, and Oracle could say itself that some indexes aren't used. Why haven't you done it? Because lack of time, or what's the reason?
Lack of trust. Lack of we didn't use index monitoring because we've decided to delete drop all indexes. So there wasn't a need to monitor it, but for the monitoring solution, yeah, it's it's for me it's not safe. Yeah, if for example if an index is used, yeah, it doesn't mean that it is useful. Yeah, there could be that there is in cost a difference of 0.003 whatever cost difference and make one index used instead of another index. Just an example. So you could well drop index A and keep index B, yeah, and the difference would be non-existent, yeah. But if you monitor, the optimizer goes for one index and for the other index, once for this, once for that. So that it is used is no safe criteria that you cannot drop it. I believe in much more in thinking, yeah, in a concept. So instead of monitoring, even when an index is not used, it's not safe because it could be used once a year for your year's end process, and then you desperately need it, and it will spoil your Christmas time.
Got it. And the last question. So your optimization was considered only through proper indexes rather than create baselines, hints, or something like it. So have you just new index and everything works fine? So probably some no baselines.
No, we didn't need that a lot. No, it was used before. You know, with the other index structure, yeah, there was a lot of patching up the statements and so, yeah.
Got it.
Mm-hmm.
Thank you.
But it doesn't mean I've never used it. Yeah, I know it, I can do it, and I use it, but not in this case. The indexing was good. We didn't need anything.
Do you try this method for other databases?
Yes. For other companies, yes. But all Oracle. Yeah.
Yeah. Maybe you try on Postgres and a SQL. Do you have this experience?
No, I don't. I wouldn't. You know, you need pretty good knowledge about the internal structures to understand where your information is stored.
Yes, that's the main problem.
That's this, yeah. So that's why. But it could be used, you know, the method is generic. It is not this database, and all relational databases work the same as far as I know.
Hello, my name is Mike. I have a little question just to be sure that I understand clearly. So as a developer, when I understand that I need a new table in a database and I create table, I should never create new index, but just wait for statistics. Yes?
No.
That's your advice?
No, that's not my advice. Because you can't do that. Yeah, you have to come up with something as a developer. Yeah, but the advice is if the things go really bad, and if you have problems that you cannot control, yeah, it might be a good idea to rethink indexing, yeah, later on, yeah, because then you need the data, you need the application running, yeah. Obviously, if you don't have that, then you don't have your facts. But this is something. If you're really in trouble, and one of my customers recently used a method because we had constantly statements which were switching the plans, yeah, so for example, we had one statement that was used to run for 5 minutes, and then for years. And then it switched the plan and ran and broke after 12 hours. And think about that. It happens on the monthly batch during the night. You're so dead in the water after that. You know, this is a horrible thing to happen. And here we analyzed why did this plan switch happen, and we found out that the index structure was not ideal. Yeah, we had these two indexes; they were both not good. Yeah, and the cost difference between those were rather tiny. Yeah, so it could go for one or the other. The optimizer could go for one or the other, and it could always happen. So we need a good index structure, it makes it much more stable. So this is, if you have a situation like that, then think about this. It could save your nighttime sleep.
Hello, my name is Sergey. We have some products which works a long time, and of course rebuild inks is time consuming. And I'm afraid to use this solution. But sometimes my colleague come to me and ask, "Oh, Sergey, we have 26 index for this table. We don't know which of these is used now, and we want to drop some of these index, but we don't know what index. What you can offer in this situation? Because in productions, I don't think I'm afraid to use this method. You advise.
I understand. Yeah, it's you do need some courage for that. Yeah, but it is no way. It's no way. You can test it rather well. You know, we had, when I wrote this little tool that I made for Oracle. Yeah, it was in pure SQL, and probably can do that for Postgres, and it didn't only sample the column combinations, it also sampled the statements. Yeah? So it was sampling the statements that were accessing the database, and I was also sampling the bind variables, and then I also sampling the number of buffer gets that was needed to process a row. Yeah? And then I made a replay component, yeah, which after we changed the index structure on a desk database, we did run then the replay and checked before and after, yeah, and then found out what has changed, yeah. Is it got worse, or is it not got worse? Is it now okay, yeah? So this is the best test you can do. This is really the only thing you can do. And what you could do, what we did for other customers, you could go for one table at a time. Yeah, we do not need to do all the indexes. Yeah, you could pick your most important tables, or for a start, maybe not that much important, but okay important tables. Test it for one table, see how it works, gain trust, go on for another table. Yeah. So this is what I also did for customers, and yes, this test tool is very useful to have, and it will give you a better feeling. Yeah. I was writing this for my customer, and half a year later, Oracle Real Application Testing was released. Yeah. So I said, I'll bet for my customer he could have gotten that from Oracle instead of me, which is a more advanced product and so on. But I found out that Oracle was charging $500,000. So okay, they're fine up with the tool that I wrote, and they're still using it. So, so you could do that. Yeah. Sample the queries and have your own test set, and then you run it against, and you measure how many buffer gets you have before and after, and if you see that they're doing fine with this index structure, then let it fly. Sometimes some risk is needed. Yeah.
Коллеги, последний вопрос, уже время поджимает. Last question.
Hello, my name is Alex. One question about the order of the column order. Like you said, that's the highest frequency columns should be on the first place. But for instance, the Tom Kite said, I read one day the article of Tom Kite, and he said that it doesn't matter the order, the column order in the composite indexes, and the only one exception is that when you create the composite indexes, actually when you just try to compress the indexes. In this case, the
I got
index with the less cardinality in the first place
Mhm,
is the best way. What do you think on this? What's your opinion in this case?
The least
it's one of
cardinality in the
controversial question
first place
because-
is about compression. Yeah,
Yeah.
I know that article
So
from
in this
Tom.
case, what we should do to
Yeah.
make the composite indexes with the highest frequency on the first place, or with the
This is a different question. You have to see that these are two different questions. Tom was talking about one query, one specific query. If I have a query which is column first name, last name, it doesn't matter if I do first name on the first place and last name on the second, or vice versa. It makes no difference because internally it's treated as one string, yeah, for the search. Yeah? And this is one of the indexing myths, that you have to put the most selective column in the first place. Bullshit, most of the time. Yeah. So he was talking about one query with a given search criteria. Yeah. I was talking about a whole index structure, and I want to maximize reuse. Yeah. So this is different thing. Yeah. I was thinking about how is the best possible reuse. Yeah. So,
Okay.
yeah,
Okay. Thank you.
you're welcome.
Коллеги, к сожалению, время поджимает. Thank you.
You're welcome.